Hey everyone, let's work through one more example of linear regression with your calculator. This is just from a set of data that I sort of pulled off a website online. Remember to start out, you're going to hit the Stat button, and then your very first option here is Edit. That's where you go to type your numbers into your lists. And if you have numbers there already, you're going to go up to where it says L1 and hit clear and then enter, not delete. Make sure you don't hit delete, hit clear, and then go up to L2 and hit clear and then enter. Okay, let's head over to where I pulled up this data, and this came off of actually a website for an MBA program, which is like a Master's of Business. So this is another place where this type of thing would be used. And this is looking at, in a particular month, this is a digital electronics company, how much they made in sales versus how much they spent on advertising. Now, I do take issue with this set of data a little bit, and this is what happens when you pull stuff offline. The way they have this set up, it looks like the sales should be your X values, meaning they should be your L1. But we don't look at advertising as depending on sales. We look at sales depending on advertising. Let me say that a different way. A company would decide how much they were going to spend on advertising and then look at the effect that that had on its sales. They would not decide how much they were going to spend on advertising based on what their sales already were. So this is like our independent variable. This is what we are controlling, and we want to see what effect does this money have on the sales that we're making. So really this should be like our L1 and this should be our L2. And normally you won't have to try to sort that out. Right now I'll always tell you which one I want you to use as L1, and it's usually the first one. But this one I'm going to use this second list as L1. So back on my calculator, let me zoom this in for you a little bit. Maybe slide this over. Okay. So in L1, I'm going to put the advertising cost. So I'm doing the second column here. So 5.5, 5.8, and I'm putting that whole list. I want to make sure I have 12 numbers total when I'm done. Yep, I have all 12. And then in my L2, I'm going to list my sales. Again, because I want to say, if I spend this much on advertising, what would that do to my sales? So I want the sales to be my Y's. So 100, 110. Okay, and once I have my data in there, now I can start doing some calculating. I think I'll pop that back to full screen there. And I've typed up some questions. These are the types of questions I would typically ask you at this point. So just to kind of work through them together. To get my line of regression, really to get all of this information, after I have my data in the list, I'm going to go back to that Stat button, go over to Calc at the top, and then option number 4 is linear regression. So let's go down to number 4. If you have a calculator like mine, at this point you're going to go down to calculate and hit enter. If it just comes up and says lin reg up at the top on a blank screen, you can just hit enter at that point. And really all of those crazy numbers on that screen, those are telling you your line of regression. So it gives it to you in the format y equals ax plus b, which is really similar to slope-intercept form, and then it tells you what to plug in for a and b. Now these numbers can be rounded, but I wouldn't round them too far. Gosh, this is going to be a weird one because, well, I guess I don't really have a choice but to go 13.9 unless I go out really far. So my line of regression here would be y equals 13.9x plus 28.65. So again, I just took that from my a and my b. My a goes in for a there, it's my slope, and then my b goes in there. That would be my y-intercept of this line. Correlation coefficient, remember that's r, not r squared, it's r, so this one would be 0.891. And then this says interpret, which interpret means tell what it means, the strength of the linear relationship based on the correlation coefficient, which remember the correlation coefficient was this right here. So what I want to know is how strong is this relationship? Well, remember 1 is perfect, so 0.891 is pretty strong. It's strong, and it's positive because there's no negative sign there. Which means in terms of what this is talking about, as your advertising dollars are going up, so are your sales, is what this is showing you. So this is strong positive correlation. Now, interpret the slope. This is a totally different question, and people mix this up with the correlation coefficient all the time. The slope comes from your linear equation up here. This number is your slope, okay? And remember, slope you can always write as a fraction. It's going to look kind of weird when it's already written as a decimal, but I could call it 13.9 over 1. And here's the reason I'm doing that. Remember, slope is made up of two parts. It's made up of your y's. It's your change in y over change in x, or rise over run. It's how much your y values are changing versus how much your x values are changing. Well, in this case, we're not really talking y and x. We entered all of our numbers into lists. So y is L2 and x is L1. Okay? And list 2 in this problem, list 2, if I go back to look at my lists, remember these were my sales. And list 1 was my advertising. So this is how much I'm spending on ads. So if I connect from here to here and from here to here, okay, here's what this is saying. For every $1 I spend on advertising, I would expect my sales to go up by 13.9. And actually, I take that back because this problem was in thousands. Okay, the data that I was given back in that table said it was in thousands. So this is for every $1,000 I spend in ads, I would expect my sales to go up by 13.9 thousand. Okay. For every $1,000 in ads or in advertising, because I didn't really need to say my sales, just sales will increase by, let's see, 13.9 thousand would be like 13,900. Okay, so again, this is something companies would use, excuse me, to make decisions about how much they want to spend on advertising based on what their projected sales are. Okay, so for every $1,000 I spend in advertising, my sales will increase by that much. And again, that came from the A value back here in my line of regression. Okay, and the last question said, if a company had $114,000 of sales in a month, how much would you expect them to have spent on advertising? What you have to ask yourself here is this number that you're given, is this your Y or is this your X? Remember, the sales we used as our Y, okay? So I'm going to take this 114,000 and put it in my linear equation in place of Y. So I'm going to say 114, and I'm putting 114 instead of 114,000 because remember, we're measuring everything in thousands. So 114 equals 13.9x plus 28.65. And now I'm going to solve that just like I would solve any other equation. Sorry, I didn't realize I was off the screen there. So again, I took this 114 and put it in for y up here in my linear equation. So when I've got this equation, I'm going to subtract 28.65, subtract For this, I can go back to just my regular calculator screen. So 114 minus 28.65, and I get 85.35 equals 13.9x. Now this is gone. And now let's divide by 13.9. And I get 6.14, which I'm just going to call 6.1 because that's where all my other x values were rounded to. So I would have expected them to spend 6.1 thousand is like 6,100. Okay, let's see how realistic that is. Let's go back and look at that list of data again. And let's see. If I have 6.1, do I actually have 6.1 anywhere? I don't, but I have a 6.2, which is awfully close. For 6.2 thousand in advertising, I get 117 in sales. So it's pretty reasonable that 6.1 would get you 114. You just want to make sure that those numbers kind of fit within your data. Okay? So that's how you handle a problem like that one. That's how you interpret the slope. That's how you interpret the correlation. And this is something that you would walk out to a company and say, this is why you should increase your advertising. You know, if you were working for a marketing company, this would be your pitch, because for every $1,000 you spend in advertising, you're going to be able to increase your sales by, you know, $13,000, almost $14,000. Okay, so again, this is a way that data can be used to persuade somebody to do something.